So what chapter is this? This is chapter 2. We're doing a long division of polynomials. Okay. Polynomial division. They want us to find the value of k by dividing x, is it minus or plus 3? Plus 3 when the remainder is 2. Okay. So we can set this up just like a long division question. Okay. Now, the only difference is we start with x to the power of 4. Now we technically need to include x to the power of 3. Okay. What coefficient is it going to be 2? Do you know? Because if you look through this, we got to go in order, right? We have exponent of 4, and then it jumps to the exponent of 2, exponent of 1, and then you could think of this like the x to the power of 0, really. Okay. So what coefficient will we put 3 to in this case? Yeah, that's right. So we put plus 0 x cubed minus 2x squared plus, here's our k. Minus 4. Okay. So we're going to go through this process of dividing them, right? So in the first one, what would we be multiplying these by?
X cubed.
Okay, yeah. So we multiply by x cubed. We'll do it by x, it's fast. X cubed. So we multiply x by x cubed, we get x to the power of 4, and we get what?
3x?
Yep, 3x cubed. Now, same idea, we still subtract just like in long division.
So we get 3x cubed.
When we subtract, yeah, negative 3x cubed. Oops, it's not cubed. Okay, and then what do we do?
And then the next one.
Yep, bring this down. Okay, what do I multiply our divisor by in order to go into this? Remember, we always want to eliminate the first one again.
Yeah.
Negative 3x squared. Yeah, negative 3x squared. Negative 3x squared.
Times 3 is negative.
Yes, that's right. Negative 3x squared is negative 3x cubed. And that's going to give us a negative 9x squared. And again, we're going to subtract them. Okay, so when we subtract those, negative 3 subtract, negative 3 gives us our 0. Here, negative 2x squared, subtract that, it's like adding, so we get what? Yeah, positive 7x squared. Now, we're going to bring down the k x, okay? So what we want to do is we want to try to work backwards from here. We know we're going to get some value, okay, for this here. And essentially we're probably trying to get rid of, we're obviously going to try to get rid of the 7x squared, right? So that's the next thing we're going to divide by. So the next thing we're going to divide by, what would we multiply this? To get that 7x squared. Positive 7x, right? So then we're going to get positive 7x, and what are we going to get over here? 21x, okay? So this becomes obsolete when we subtract. Now this is the interesting part, because we know what's going to happen next is we're going to bring down the negative 4 to whatever it is. Oops, and we're going to end up with a remainder of 2. Okay, so in the end, when we subtract, we're going to have a remainder of 2. Okay, so we got to think this one through here. Okay, so in order to make this remainder 2, this number here needs to be 6, right? Positive or negative? When we subtract it, oh yeah, this makes sense of this. It's going to have to be negative 6. Good. So we're going to need a negative 6. In order to produce a negative 6, what would we be multiplying this by? Just 2?
Multiply the 3 by?
Yeah, well, because the 3 is going to be the constant term at the end here. Okay, so what will we be multiplying this positive 3 by in order to make it negative 6? 2. Okay, so we'll repeat that part. So the goal is, we know that whatever term this is, we're going to be multiplying it by this, and it's going to create this line. Okay, and we know that the 3 is going to create the negative 6. So we'd have to multiply by negative 2, okay, in order to get that. So when we multiply this by negative 2, we're going to get negative 2x minus 6, okay? Negative 2x minus 6. Do we miss a line going through this? Yeah, we do. We've got to move this over 1. Sorry, just move that. Technically, he's over 1, right? Where is he?
There's no number between them.
Yeah, there shouldn't be. Let's double check. Yeah, so that's fine. So we know what this is here. So here's the key. This is what's important now. We have k to the power of x minus 21x is going to equal what? Yeah, because remember, we're always trying to eliminate that number. So we know that number is going to be negative 2. We just kind of bring it up from before here. Okay, we know it has to be the same as that so that we can eliminate them. So essentially, we turn this into a quick little equation. We know that k is going to be
positive too, actually. Or no, it would be negative.
negative because of subtracting, yeah. So k, minus 21 is going to equal negative 2. Okay? We bring 21 to the other side. We get k is equal to negative 2 plus 21. K is equal to what? 19. Good. So what this says is, and let's make sure this idea works, it's saying that our k value should be 19. So if k was 19, okay, let's work through this. We multiplied this 7x times that, we would get 7x squared plus 21. 19 minus 21 would give us negative 2. So we have negative 2x minus 4. That's what would come down. We would then multiply by negative 2, right, to get rid of this. So we'd have negative 2x minus 6. These cancel out. Negative 4 minus negative 6 gives us a remainder of 2. So that's our check. Okay, say we did this through synthetic division. The question, do you remember what the polynomial was? Where is that? It's not this page. There it is. Polynomial is x to the power of 4 minus 2x squared plus our kx minus 4, right? And the goal is to find the k. Well, with synthetic division, what we're trying to do is we're trying to, you can only see it up there too if you're hurting your neck.
I'm not hitting my neck. That screen's too bright.
Okay.
For me.
With synthetic division, same idea. We need to get a value for x cubed, so our coefficient will be 0 with that one. So we always take the coefficients of all of the numbers here. In this case, it's k and 4. So our first one is 1, next one is 0, next one is negative 2, next one is our k value, next one is negative 4, and what's the number going to be at the bottom? 2, because we know the remainder is 2, right? So we bring down our 1, and then through synthetic division, negative 3 times 1 gives us negative 3. We subtract. So we add the values, we come down with negative 3. Okay. Negative 3 times negative 3 gives us 9. And we add these values, we get 7. Negative 3 times 7 gives us, remember that number when we were doing long division? Do you recall it at all? Yeah, right. So 21, okay, and we know that it's going to have to equal some number here that when we add, we get 2. So what's this number going to have to be in order for our remainder to be 2? Yeah, it's going to have to be positive 6, right? Positive 6. So we work backwards now. What number do I fill in here that when I multiply 3 by this number, we get positive 6? What negative 3 times what gives me positive 6?
Oh, 2.
Yeah, negative 2. So now, through our addition, we do our column, right? So k plus, well, plus negative 21 is like k minus 21 equals negative 2. Bring the negative 21 to the other side, comes positive. K equals 19. Synthetic division would be faster to do it. But either way, we can work backwards to solve this. It's a thinking type question. Okay, question 7 says, list the values that could be zeros of this polynomial. So we have this polynomial. You plugged in numbers, and you discovered that when x is equal to 1, this is all 0, right? Well, let's just double check. 1 cubed minus 3, 1 squared. 1's a nice easy number to work with, so we can probably do this out. Yeah, worked out good. That's me, don't worry. Yeah.
I used to have that as my.
So 1 cubed is obviously 1. 1 squared is 1 times 3 is negative. 1 times 4 is 4 minus 2. 1 minus 3 is negative 2. Positive 4 minus 2 is positive 2. 0. So we know that works. We could do long division or synthetic. You chose to do synthetic, so we take the number 1. We bring down the coefficients. Coefficients in this one are the number 1, negative 3, 4, and negative 2. Okay, so this is what's going to tell us once we divide it what our new polynomial is going to read. We bring the 1 down. 1 by 1 is 1. 3, negative 3 plus 1 is negative 2. 2 times negative 2 plus 4, 2. 1 times 2 is 2. 0. Okay. So what this is saying now is if we were to divide this in, okay, if we were to divide that, and because x is equal to 1, that's like saying x minus 1. It's like dividing that term, right? So what we've done is we factored that polynomial. We now have x minus 1 multiplied by, and our original one was to the power of 3, so the new one's going to be the power of 2, right? Coefficient is 1 to the power of 2. This is our coefficient. Then minus 2x, yes, 2x plus 2. I should do these all in the same color. So plus 2x, and then plus 2. Okay. There are no extra constants to put at the end because our remainder is 0. We could say add 0, but it really doesn't mean anything. Okay. So we have our 1, 0 now. Now what we can do is to discover if there's any more zeros, we need to find, we need to factor this.
It can't be.
Yeah, so essentially the way to prove it, because if your teacher asks you to prove it, we can try our factoring where you take the factors of the first term and last term. Do you remember that?
Yeah.
Yeah. We can try that quickly, but that doesn't technically prove that there's none. There's a formula that will prove there's none. Yeah, quadratic formula will prove that there are no more factors. So our x is equal to negative b, which is negative 2, plus or minus the square root of b squared, which is 2 squared, minus 4, a is 1, c is 2, all divided by 2 times our a is 1. Okay? So we get negative 2 plus or minus the root of 4, negative 8. And this is going to tell us right here. In fact, we didn't even have, I should have mentioned that. Yeah, exactly. So we're going to end up with a negative root, which means there is no number. Okay, we can't square root a negative number. Another way we could have done that is, do you remember the discriminant? Did you guys use that at all?
Just the 4ac.
Yeah, just using this part of it. If you were to prove that there's no more zeros, that's one way you could find out. By just using the b squared minus 4ac, we plug those values in. That gave us 2 squared minus 4 times 1 times 2. Okay. And we got 4 minus 8, which gave us a negative number. If this is negative, that means there are no roots. Okay? And what that is it doesn't mean there's no roots in general, it just means that there's no roots to this part here. So the only intercept we had was here when we did that division. So we need to factor this, is what they asked us. So factor. First number you try, right? We got to go through our trial and error method. We're going to try x is equal to 1. So we plug in x at 1. 3 times 1 cubed plus 8 times 1 squared plus 3 times 1 minus 2. Right? We're going to get 3 plus 8 plus 3 minus 2. That's going to give us 6 plus 6. Is that right? Which just gives us 12. Is 1 a factor? No, it's got to be 0, right? So then we try x equals 2.
I'll do -1 because I think that's the answer.
Oh, okay.
Use the negative.
We can try the negative one. The negative one will make that negative. Okay, obviously they'll all be negative, but it'll make 2 of the answers negative when we're going through it. Compare. So we'll just erase this part because we have the same knowledge. This will end up being -3. This will still be +8. This will be -3 minus 2. Yes. -6 plus 6, 0. Perfect. So x equals -1 is one of our answers, or one of our factors. So let's go through our synthetic division again, right? Because it's a nice fast way to do these things. So x is -1. Our coefficients were 3, 8, 3, and -2. Okay? So we bring the 3 down. -1 times 3 is -3. 5, -5, 2, 2, 0. Beautiful. Okay. So we've got our first set right now. In our polynomial, we know we have x plus 1, because this is negative, so we make it positive, right? And what was our first one we started with? Was it cubed? Yeah, so it's cubed. So our next number, coefficient for 3x squared plus 5x minus 2, no remainders. Does that make sense? Okay. So we've done that. Now we've got to try factoring. Okay. I'm going to try factoring it the easy way first. We could do the quadratic formula, but I just want to see if this will work. So we take the factors of the first terms, factors of the last terms, and their products need to add up to the middle one. Are you familiar with this type of factoring? Okay. When we go through this, this will give us 5x and 1. That won't work. 1, 1. Let's see if this will work. 2x and 3x. But they would both have to be positive. So it won't work that way. Does that make sense to you? So that won't work that way, so we got to try our quadratic formula to factor this. So same idea, this is our a value.
Do you just relate the discriminant thing, or is it like...
To see if there are any more roots?
Yeah.
That's a great idea. Let's put it into the discriminant formula. So we have our b squared minus 4ac. Are there any more roots in this question? So our b is 5 squared minus 4. A is 3. C is -2. Oh yeah, there's going to be. How do I know? Because we're going to have a negative times a negative, so that's going to be positive. So we're definitely working with positive numbers, okay? So in case you just didn't pick that up.
Yeah, once I saw the negative,
Yeah.
C.
Yeah, so that's going to be 8 times 3 is going to be 24, right? So that's going to be 49. Oh, that's good. Watch. What that means is maybe do we make a mistake going through this? We'll see. So put in our quadratic formula. X is equal to -5, okay? Plus or minus the root of. Now, we actually just solved for the brackets, the b squared. So what did we get? And did we do it right? Let's just double check. 4 times 2 is 8. 8 times 3 is 24. Plus 25, that's 49. That's right. So we've already solved for those brackets. Divided by 2 times a, which is 2 times 3 is 6. Okay, so we're already jumping ahead here. -5 plus or minus 7 divided by 6. We split this equation. And we get 0 equals -5 minus 7 divided by 6. 0 equals -5 plus 7 divided by 6. This will give us -12. Is that right? Divided by 6. -2 is one of them. Sorry, I don't know why I said 0. It's x. X equals -2. And in this version, we get, yeah, 1/3. So x is 1/3. Now we can reverse engineer that so that it becomes, well, we're going to put them into brackets, right? So if we want to put everything into brackets, we already had x plus 1 as one of them. In the other bracket, we want to set it equal to 0, right? Because we're trying to find zeros. So x minus 2, whoops, sorry. Yeah, we'll just work through it just so to make sure you understand. Equals -2. To set it equal to 0, we bring the 2 over. X plus 2 equals 0. So that's one of our brackets, x plus 2. And in our other one, x
Oh,
no,
you can do 3x.
Yeah, we'll bring the 3 over, so we get 3x equals 1. So it's going to be 3x minus 1 equals 0 in this one. So our other bracket is 3x minus 1. That would be our factor form for this question. Okay? Does that make sense? Okay, so we look at the next question. We're putting the sum of cubes formula up there because we've cheated and we looked ahead and we know that this is a sum of cubes. So 125 y cubed. Okay, so we obviously need to put it into this. A and B is the cubed roots of these two numbers. So first off, we'll do some side calculations. Okay, before we start going anywhere, we'll do some side calculations. The cubed root of x cubed is the cubed root. Do you know what that is? It's just x. X times itself.
You cross it out.
Yeah, exactly. Now this one's a little different. 125 y cubed. Cubed root of this. And what's going to be? What's the cubed root of 125? You can put it in your calculator if you want.
No, so I guess so. Is it 25 or
125. That's right. And what's the cubed root of y cubed? Or y to the power of 3, yeah.
Just y?
Yeah, so together it's
5y.
5y. So when we go to do the first part of these brackets, x plus 5y. Now what we're going to have to do is we're going to have to square these. Okay, so our a term squared. What's our a term squared? X squared minus a times b. Well, our a term is x and our b term is y, so we get 5xy plus, and then we square 5y. What will that give us? 25y squared. Yeah, it's squared. Okay, it's squared. So we've got that part there. Now we actually might be able to factor this farther, that part. We're going to have to double check. Okay. Let's check our factors of the first terms. It will be x, 1x and 1x. Factors of this are 25y, 1y, and 5y and 5y. Their products need to negative 5xy. Quickly looking at this, are we going to be able to get it? No, it's not going to work. So this is what we're looking for as an answer. We'll rewrite it at the end. Our factor form is x, unless there's a common. Sorry, we should always talk about greatest common factor. Is there a greatest common factor here?
I forget. I used to.
Greatest common factor is one term we can divide everything by.
Oh, okay. 5?
I can't divide the first term by 5.
So
right?
no.
Yeah, so there's nothing. So this would be our answer. Okay, that's what we're looking for. So our state the simplified equation of the cubic function with these x-intercepts. Okay, so the x-intercepts are 2, 3 plus root 5, and 3 minus root 5. So what they're talking about is kind of like a difference of squares here. But we can set it up the way you did. And a y-intercept of 40. So if the y-intercept 40, that's when x is equal to 0. That's what they're talking about. When x equals 0, this is 40. Okay? So we need to solve. First of all, let's set up our factor form of this. We're going to have a y is equal to, there could be an a term. We really don't know. Not yet, at least.
You have to just multiply by a or something?
Well, let's set up our factor form. So x-intercepts, that's going to be, first one's at 2, so that's going to be x minus 2, right? Mm-hmm. Now in our next one, we're going to have x, because this value, the opposite of it, yeah, 3 plus 5, and x minus 3 minus root 5. Okay. Technically, there should be a third. Okay. So here are our forms. Now, this is a thinking part because we have to recognize that this is a difference of squares. Okay, the type of factoring we had learned maybe the year before. The difference of squares is similar to a difference of cubed. A squared minus b squared is equal to a plus b, a minus b. So we have that here. So what we need to do is we need to take this term and square it, and take this term and square it, and just put it into this form. Okay? So in other words, what we're saying is we're going to take the first term and square it, and we're going to take the outside term and square it. Right? Wait a second. Okay, so instead of our difference of squares like we were saying before, let's actually just FOIL this out. Okay? We'll leave the first term by itself. We're going to FOIL this out just so we are no longer working with any radicals here. So we still have an a value, x minus 2. When we FOIL this out, we get x squared, and then we get minus. So when we FOILed that out, because of those terms. So what's going to happen here is we're now going to do x times, so if we did our first terms, x times x, outside terms, x times negative 3 minus 5x. So that's going to look like this, x times.
But doesn't that just cancel because of the positive and
This term here is
a
little different.
And then that's negative and then that's positive.
Okay, we're just going to make sure. So x times that is negative x times 3 minus root 5. Okay, and then we do our inside terms. So that becomes minus, again, x times 3 plus root 5. Okay, and then when we multiply those two terms together, we need a little more room here. To multiply those two terms together, we get negative times a negative. So we get positive 3 plus root 5 times 3 minus root 5. Does that make sense? For our FOILing? Okay. So then we get y is equal to a, x minus 2. Well, these two here, those numbers in the back, we've already established they're going to be positive 4. Okay, so it's going to be plus 4 in the end. And we're going to have x squared. This part we have to double check. Okay. Essentially what this is going to be is we can't put them together because these terms are not the exact same term in terms of their coefficient. Well, no, if we evaluate just this number and this number, they don't evaluate to the same number. Okay? So what I'm going to do is I'm going to distribute in here to make sure if we can cancel anything else out. So I'm going to get negative 3x plus root 5, negative 3x minus root 5 plus 4.
Yeah. Cancel with negative 6. That's what I got. Yeah. I just don't know how I did that.
Yeah, so we did that there. That gets that, and we get our negative 6. So we just want to double check. So it looks like you got that part anyways. Oops. So ax minus 2x squared minus 6x plus 4. Beautiful. So we're working along here now. Now,
to multiply all of that.
Yeah. So we get y equals. Now let's leave the a on the outside. And we'll do this times all the terms. So we'll do it in blue first. So x cubed minus 6x squared plus 4x. And then we'll do it in red. Negative 2 times that is negative 2x squared plus 12x. And then minus 8. Okay. Now that we have that, y is equal to a. We only have x cubed, like terms. Negative 6x minus 2 gives us a negative 8x squared. 4 and 12 are 16x minus 8. Okay. Now when we finally go through this,
And you have to put the 40 in.
yeah.
For y.
So when y is 40 now, we plug this in, we get 40 is equal to our a value.
Oh, I know I did it wrong now. I said for a, but then...
There. So we have our a, but this is actually when x is 0. That's what a y-intercept is, right? So we all know all of these x's, we can substitute 0 in for them. Plus 16 times 0 minus 8. Okay. Well, what's going to happen is we have 40 equals a. That's going to be 0 minus 0 plus 0 minus 8. So now we get 40 is equal to negative 8a. Okay, all those zeros cancel out, negative 8a. We should really do page width, much easier to see.
40 divided by 8.
Yeah, so 40 divided by negative 8 gives us our a. It's still negative on the outside. So we get negative 5 is a. So now when we plug everything back in, because this was our important part, what we had here, we plug in negative 5 for this value. So we have, we'll do it in red now for our final answer. Y equals, our a value is negative 5 times x cubed. X cubed minus 8x squared plus 16x minus 8. Does that make sense? And then finally our distributive property through here. So y equals negative 5x cubed plus 40x squared minus 80x plus 40. And that makes sense for a y-intercept because if we plug in 0 for all these x's, they cancel out. 40 would be our y-intercept. Okay? So that would be our final answer here.